Long before we built cities or lit up the night sky, our ancestors lived in the dark. On the prehistoric savanna, early humans were nowhere near the top of the food chain. We were a vulnerable target in a landscape teeming with threats. Look at the skull of Homo erectus. Compared to the massive, armored, and highly adapted predators of the era, our early ancestors were physically outmatched. We lacked sharp claws, thick hides, or the raw muscle to fight a direct attack. When the sun went down, survival meant hiding. Without night vision, the dark was blinding to us, while giant hyenas and saber-toothed cats possessed acute hearing and smell. The only defense was to retreat into caves or up into the trees and wait out the freezing hours. Our ancestors were caught in a biological trap. This animated model of the digestive system shows the heavy toll of a raw diet. Chewing through tough, uncooked meat required immense physical effort, burning through a large portion of the calories that food provided. This raw diet exposed them to bacteria and parasites, keeping life expectancies low. More importantly, the sheer caloric cost of basic digestion placed a hard limit on our evolutionary timeline. The body simply didn't have the spare energy to fuel a larger brain. They were also physically contained. Lacking the ability to stay warm, hominids were restricted to the temperate zones of Africa and Asia. The freezing temperatures of northern latitudes formed an invisible, impassable wall. Physically outmatched, neurologically capped, and geographically confined, human evolution was stalled. Progress required an external catalyst, a force entirely outside of our biology. For millions of years, fire only came from the sky. When lightning struck a dry forest or a volcano erupted, the immediate and only response from early hominids was to run. Eventually, observation overcame panic. They noticed that apex predators, the giant cats and wild dogs, were terrified of the flames and kept their distance. And when the smoke cleared, the animal carcasses left behind in the brush were softer, easier to chew, and far safer to eat. They couldn't spark a flame themselves, so they had to steal it. This was fire foraging. When a natural blaze occurred, ancestors cautiously approached dying embers to retrieve a burning branch. This began the first torch processions. Carrying a smoldering piece of wood back to a cave meant walking slowly and shielding the flame from the wind, trying to keep the fragile ember alive until it could be fed with dry twigs. We can track this deep underground. In caves like Wonderwork and Jaucadian, researchers found burned plant matter mixed into ancient sediment. The numbered markers descending through rock layers show ash accumulating over time, proving humans continuously maintained these stolen flames. By capturing a terrifying force of nature, they built a reliable perimeter of light and heat. The dark was no longer an absolute threat. Relying on nature meant the supply was fragile. A sudden downpour or a few hours of neglect could extinguish the embers completely, plunging a group right back into freezing vulnerability. True independence required the ability to generate a flame on demand, entirely from scratch. The first reliable method was percussion. Early toolmakers realized striking flint against an iron-rich mineral, like pyrite, produced a shower of hot sparks. If those sparks landed on dry moss, they could catch. At the Burnham site, archaeologists uncovered combinations of burned materials alongside these exact types of flint fragments, dating back 400,000 years. These were the early ignition switches of human history. Another technique relied entirely on friction. By rapidly rotating a hard wooden stick into a softer piece of wood, the intense rubbing generated enough heat to create a smoldering core of wood dust, which could be blown into a full fire. With the knowledge to spark a fire anywhere, humans ceased to be opportunistic scavengers. They could manufacture their own environment, carrying the power of a lightning strike in their hands. Controlling fire triggered a biological reaction within our own bodies, best explained by a scientific framework called the expensive tissue hypothesis. Fire essentially functioned as an external stomach. By roasting tough meat and fibrous tubers over a flame, the heat broke down complex proteins and carbohydrates before the food ever touched human lips. This chart illustrates the body's energy economy. On the left, a raw diet forces the gut to burn massive amounts of calories just to digest the meal. On the right, cooked food digests easily. This massive energy surplus allowed the human digestive tract to physically shrink, freeing up biological resources. Those freed up resources were redirected to our most energy-hungry organ. Fueled by a consistent diet of high-calorie, easily digestible meals, hominid brain volume began a rapid, steady expansion over the next few 100,000 years. The hearth functioned as an anatomical forge, providing the biological fuel required for human intelligence to expand. Equipped with portable heat and higher cognitive function, the old geographic borders collapsed. Humans began migrating out of the warm savannas, pushing deep into the freezing winters of Europe and Asia. They also applied this new technology offensively. By heat-treating rocks, they could flake off sharper, more durable edges. They roasted the tips of wooden spears to harden them, turning simple sticks into lethal, armor-piercing weapons. At the end of the day, the fire became an anchor point. Gathering around the hearth extended the waking hours, providing a space to share hunting techniques, trade resources, and accelerate the development of complex language. The chemical reaction that kept cave bears at bay is the exact same process of combustion driving our modern infrastructure. We still use concentrated heat to melt metals, power our grids, and push our machinery forward. By learning to tame a single spark, a physically outmatched primate managed to reshape its own anatomy, build global societies, and ultimately propel itself off the very planet where it once hid in the dark.